In the early years of the Second World War, Germany was not only fighting across land, sea, and air, it was also fighting an invisible battle for the future. While tanks rolled through Europe and cities burned under bombing raids, a quieter war unfolded inside laboratories, research offices, and military planning rooms. This was a war of ideas. Some were practical, others were desperate, and a few pushed so far beyond existing technology that they bordered on the impossible. Among those ideas was a concept so extreme that it still sounds unreal today. A weapon not launched from the ground, not carried by aircraft, not delivered by missile. A weapon placed in space, a weapon that would use the sun itself as a tool of destruction. It was called the Sonnengewehr, the sun gun. The idea did not emerge from superstition or fantasy. It came from mathematics, physics, and the growing belief among German scientists that the future of warfare would not be decided solely on Earth. By the 1930s, German rocketry was already far ahead of most of the world. Engineers understood propulsion, ballistics, and the basic principles of spaceflight. They knew that with enough speed, a projectile could escape Earth's gravity. They also knew that an object placed at the right altitude could remain in orbit indefinitely. To many military planners, orbit represented the ultimate high ground. Long before satellites became part of everyday life, German researchers imagined platforms circling above the planet, unreachable by conventional weapons, observing everything below. Some envisioned space stations, others imagined reconnaissance platforms. A few went further and considered space as a battlefield. The sun gun was one of those ideas. The basic concept was deceptively simple. Place a massive concave mirror into orbit around Earth. Shape it so that it could collect sunlight and focus it onto a single point on the planet's surface. At that focal point, the concentrated energy of the sun would generate extreme heat. In theory, this heat could ignite flammable materials, damage infrastructure, or render entire areas uninhabitable. The weapon would not explode. It would not leave craters. It would burn silently, using a force that no nation could block or intercept. The idea of using mirrors to focus sunlight was ancient. Archimedes had supposedly used polished shields to burn enemy ships. Whether that story was true or not, the physics behind it were sound. Concentrated light produces heat. In space, above the atmosphere, sunlight is constant and unobstructed. German scientists understood this well. One of the key figures connected to the sun gun concept was Hermann Oberth. Oberth was not a military officer. He was a visionary physicist and one of the founding fathers of rocketry. His early writings laid out the mathematics of spaceflight years before rockets were capable of achieving it. He believed that humanity's future lay beyond Earth and that space stations would one day orbit the planet. Oberth was also realistic. He knew space could be used for peaceful purposes, but he also understood how quickly military interests could shape technology. In the late 1930s and early 1940s, as Germany poured resources into advanced weapons, ideas that once seemed theoretical began to attract attention from military planners. Documents from the period show that German research offices explored the possibility of orbital mirrors. These were not detailed construction plans, but feasibility studies. Calculations, sketches, estimates of size, mass, and energy output. The numbers were staggering. To generate enough heat to cause meaningful damage on Earth, the mirror would need to be enormous. Estimates varied, but many studies suggested a structure several kilometers wide. It would consist of thousands of reflective segments, carefully aligned to focus sunlight precisely. The material would need to be lightweight, yet durable, capable of surviving the harsh conditions of space. Even if such a mirror could be built, placing it into orbit presented an even greater challenge. Germany's most advanced rocket, the V-2, was revolutionary for its time. It was the first ballistic missile and the first human-made object to reach the edge of space, but it was completely inadequate for orbital construction. Its payload capacity was limited. Its guidance system was crude. It could not place objects into stable orbit, let alone assemble a massive structure in space. Launching the sun gun would have required thousands of rocket launches, each carrying a small piece of the mirror. Those pieces would then need to be assembled in orbit by some form of automated or crude process. No such capability existed. No nation on Earth had anything close to it. German engineers knew this. As the war progressed, the gap between ambition and reality grew wider. Resources became scarce. Allied bombing campaigns targeted factories, research centers, and transportation networks. Skilled workers were drafted or killed. Fuel shortages crippled production. In this environment, the Sun gun became less a weapon plan and more a symbol of technological desperation. It represented the hope that a single breakthrough could reverse the tide of war. But hope was not enough. By 1943 and 1944, German leadership focused on weapons that could be deployed quickly. The V-1 flying bomb, the V-2 rocket, jet fighters like the Me-262. These systems were difficult to produce, but at least they could be built and used within the war's timeframe. The Sun gun could not. It remained confined to reports and theoretical discussions. No hardware was produced. No test launches occurred. The project never advanced beyond paper. When Germany collapsed in 1945, Allied forces captured vast amounts of scientific material. Among the documents were references to orbital mirrors and space-based weapons. American and British intelligence analysts examined these ideas with interest, not because they believed Germany had come close to building them, but because the underlying concepts were sound. The Allies reached a clear conclusion. The physics worked, the engineering did not. At the time, even the United States, with its vast industrial capacity, could not have built such a system. Spaceflight itself was still in its infancy. The first artificial satellite was more than a decade away. The Sun gun was quietly archived. In the years that followed, attention shifted to nuclear weapons. Atomic bombs provided immediate, devastating power without the need for impossible infrastructure. Space became a secondary concern, at least initially. Yet the idea of using space as a platform for global influence never disappeared. During the Cold War, both the United States and the Soviet Union explored space-based weapons concepts: orbital bombardment systems, surveillance satellites, missile defense platforms. None of these ideas emerged in isolation. They were part of a continuum that stretched back to the earliest days of rocketry. The Sun gun occupied a strange place in that history. It was one of the first serious attempts to imagine a weapon beyond Earth's atmosphere. It showed how quickly spaceflight concepts could be militarized. It also revealed the limits of wartime imagination. German scientists were brilliant, but they were constrained by reality. Materials science was not advanced enough. Rocket technology was too primitive. Orbital mechanics were understood, but controlling objects in space was beyond reach. In another era, under different circumstances, the idea might have evolved differently. Decades later, humanity would return to orbital mirrors, not as weapons, but as tools. Proposals for space-based solar power stations began appearing in the 1960s and 1970s. These systems used large collectors to gather sunlight in orbit and transmit energy to Earth via microwaves or lasers. The goal was clean, continuous power. The principle was nearly identical to the Sun gun. Collect sunlight, focus energy, deliver it to Earth. The difference was intent. What had once been imagined as a weapon became a potential solution to energy shortages. This transformation highlights one of the central truths of technological history. Tools are not inherently good or evil. Their purpose depends on who controls them and why they are built. The Sun gun was never constructed. It never burned cities. It never altered the course of the war. But it remains important, not because of what it did, but because of what it represented. It marked one of the earliest moments when humanity seriously considered placing power above the planet, beyond borders, beyond immediate retaliation. It showed that the militarization of space did not begin with satellites or nuclear missiles. It began with ideas sketched on paper during the darkest years of global conflict. Today, as satellites fill Earth's orbit and nations once again discuss space-based defense systems, the Sun gun serves as a reminder. The dream of controlling space has always walked a thin line between exploration and domination. In the end, the Sun gun failed not because it was misunderstood, but because it arrived too early. Technology could not keep pace with ambition. The war ended before science could catch up, and so the weapon that aimed to harness the sun remains frozen in history. A warning, a curiosity, a glimpse into a future that almost began decades too soon.